This is section 2.2, and this is the second video in this section. And today we are going to continue talking about quadratic functions. And really today we're going to be focusing on their maximum and minimums and solving word problems. So the first objective is to determine a quadratic function's minimum or maximum value. Now right now you might be asking yourself a few questions. You could be saying to yourself,
where would the maximum or minimum be? How do I know which one the graph will have?
So take a second, think about that. Where would the maximum or minimum be? How do you know which one it's going to have? Now if we think about it and we look at two different parabolas, one that opens up and one that opens down. Hopefully you decided a parabola that opens up is going to have a minimum value, a low point, and a parabola that opens down is going to have a maximum or a high point. And I hope you also decided that that low point or high point would occur at the vertex. So to decide if it has a maximum or minimum, we're going to think about, does it open up or does it open down? And the location of that would be at the vertex. Now, we don't want to have to complete the square every single time we want to find the vertex, because sometimes we don't want to do the whole graphing process. We just want information about the vertex. So another way besides completing the square to get the vertex of a parabola from standard form is to use this idea that the x value of the vertex is the negative b divided by the 2a. To get the y value, you just have to plug that equation into the function, or plug that answer into the function to get your answer, to get the y value. Let's go ahead and just take a look at an example. Given that f of x, negative 3x squared plus 6x minus 13, first of all, without graphing, is it going to have a maximum or a minimum? Remember, we just said to decide, we're going to think about which way it opens. The negative in the front means this parabola is going to open down. It's going to be flipped over. That means it has a high point, so this one has a maximum. Now we're actually going to find that maximum. I don't want to do complete the square, so instead I'm going to use this new idea of how to find the vertex, the negative b over 2a. So to find the x value of the vertex, we just need to take negative b divided by 2a. The b value in this case is 6, so we get negative 6 divided by 2 times negative 3. Negative 6 over negative 6. It looks like the x value of the vertex in this case is 1. To find the y value, we're going to find f of 1. We're going to plug 1 into the equation. We'll have negative 3 times 1 squared plus 6 times 1 minus 13. A little simplifying gives us 3 minus 13, so we get negative 10. The maximum or minimum is at the point 1, negative 10. Now, if I ask you where is it, you would tell me 1. If I ask you what is it, you would tell me negative 10. And if I ask for the coordinates of the maximum or minimum value, you'd say 1, negative 10. The final part here, we want to identify the function's domain and range, the last piece of this question. Now, if the vertex is at 1, negative 10, and it's a parabola, we know for a fact that the domain of parabolas are all real numbers, so we'll say negative infinity to infinity. Now for the range, we'll think about the fact that negative 10 is the maximum value of this parabola. It's the high point. So it means it's going to be our biggest point on the graph. That means if I think up back here at this picture, this graph is going to go from negative infinity all the way up here to negative 10. So the range would be negative infinity to negative 10. All right. Moving on. We're going to solve quadratic functions word problems with maximum and minimums. So go ahead, take a second and read this question. All right, so in this question, we have 100 yards of fencing. We're enclosing a rectangle, and we want to know the maximum area. Now, before I can find the maximum area, I need an equation for my area. I want to know how much is my area in terms of x. We'll just call it a of x, our function. We want an equation to represent area. So now we have to think about what we know. Let's go ahead and look at this picture. I'm going to call one side of this equation, or this rectangle, x. That makes the other side x as well, because they're equal. And we have 100 yards of fencing. So right now, the fencing I have left is 100, but take away those two x's. Now, that has to get split between two different sides of the rectangle. So we're going to divide that by 2. When I do that, I get 50 minus x. So each of the other sides is 50 minus x. If you add all those sides together, you see we do get, in fact, 100 yards of fencing. So now I want to write this as area. I want to write an equation for area using the information on my picture. Area is base times height, or length times width, so it's going to be x times 50 minus x. And if I do a little distributing, I get 50x minus x squared. And now I want to know the maximum area. So we'll just go through right now and we'll find the maximum point. Looking at my equation, I see a negative in front of the x squared, so that helps remind me that this is in fact going to be a maximum because this is a parabola opening down. Remember, the first thing to do is negative b over 2a. That's going to give us the maximum x value. The b value in this case is 50. Be careful, this equation's written with the b in front, over 2 times negative 1. So we get negative 50 over negative 2, which is 25. Now that I know my maximum x value, I really want to know the maximum area. So we'll go ahead and plug that into our area formula to find the maximum area. Now you can use either one. In this case, since I don't have a calculator handy, I'm going to use the top equation because it's a little bit easier to work with. We'll have 25 times 50 minus 25. So 25 times 25, 625 square yards. Now that's not the only possibility for the area, but that's the maximum area I can get. All right, I'm going to give you a couple questions to try, and I want you to go ahead and answer these, and then you'll bring your answers tomorrow to class. Here's question number 1 for you. Determine the maximum or minimum of this parabola. And number 2, the cost in millions of dollars for a company to manufacture automobiles is given by this function, and I'll write it a little bigger. 4x squared minus 24x plus 72. And I want you to find the number of automobiles that must be produced to minimize the cost. So go ahead and answer those 2 questions, and we'll see you tomorrow.